This question asks about whether this compound has optical isomerism and geometric isomerism. Now, this compound does not have any geometric isomerism in it because for geometric isomerism, there are two criteria that needs to be met. One of the criteria is restricted rotation. One example of restricted rotation is the example of carbon-carbon double bond. Now we have a carbon-carbon double bond here and a carbon-carbon double bond here. The second criteria is that that each of the double bonded carbon atoms must have different groups on them. That each of the double bonded carbon atoms must have different groups on them, right? That's the second criteria. So now if you look at this carbon atom here has two hydrogen atoms on it. This carbon has two hydrogen atoms on it. And that is why this will not exhibit any geometric isomerism. If you look at this carbon, it doesn't have two different groups on it. Two different groups must be there, right? In order to have geometric isomerism, right? Okay. Now, this compound has optical isomerism in it. How does it have optical isomerism? Because this compound has one carbon with four different groups attached to it. It means it has a chiral center. So you look for a carbon atom here, which is attached to four different atoms or four different groups of atoms, right? For example, if you look at this carbon here, it is attached to four different groups. This carbon is attached to four different groups. That's one group, that's another group, and that's another group, and there's a hydrogen atom here. So four different groups. So this carbon is attached to four different groups because there's a hydrogen here. So there are four different groups here. That's one group, that's the second group, that's the third group, and that's the fourth group. So this carbon atom that you see is the chiral center. So the answer to question number 11A will be C. C will be the answer. All right. If you have questions, you can always write in the comment section. Thank you.